Chapter 3. Squares and Square Roots. Square. The square of a number is the product of the number with the number itself. For example, the square of 2 is 2 squared, which is equal to 2 into 2, which is equal to 4. The square of 3 is 3 squared, which is equal to 3 into 3, which is equal to 9. The square of 4 is 4 square, which is equal to 4 into 4, which is equal to 16. The square of 5 is 5 square, which is equal to 5 into 5, which is equal to 25. Perfect squares. When the exponent power of a natural number is 2, the number so obtained is called a square number or a perfect square. Thus, when a number is multiplied by itself, the product is a perfect square. For example, 1 is equal to 1 squared, 4 is equal to 2 square, 9 is equal to 3 square, 16 is equal to 4 square, 25 is equal to 5 square, and so on. Therefore, 1, 4, 9, 16, 25 are perfect squares. To find whether a number is a perfect square or not, write the prime factors of the given number. Group the prime factors in such a way that, in each pair, both factors are the same. If no factor is left over after grouping, the number is a perfect square. If any number or numbers are left whose grouping is not possible, then the number is not a perfect square. The following examples will make the concept clear. Example: find whether the following numbers are perfect squares. 441. Solution: 441, 3. 441 divided by 3, 147 divided by 3, 49 divided by 7, 7 divided by 7 is equal to 1. 441 is equal to 3 into 3 into 7 into 7, which is equal to 3 into 3 into 7 into 7, which is equal to 3 square into 7 square, which is equal to 3 into 7 raised to the power 2, which is equal to 21 raised to the power 2. Since no factor is left over, hence 441 is a perfect square of 21. 7688. Solution: 7688. 7688 divided by 2, 3844 divided by 2, 1922 divided by 2, 961 divided by 31, 31 divided by 31. 1 is equal to 2 into 2 into 2 into 31 into 31, which is equal to 2 into 2 into 31 into 31 into 2, which is equal to 2 square into 31 square into 2. Since last number 2 cannot be grouped, hence 7688 is not a perfect square of any natural number. Example: find the smallest number by which 4056 be divided to make it a perfect square. Solution: 4056 divided by 2, 2028 divided by 2, 1014 divided by 2, 507 divided by 3, 169 divided by 13, 13 divided by 13, 1. 2 into 2 into 2 into 3 into 13 into 13, which is equal to 2 into 2 into 13 into 13 into 2 into 3. In this case, two numbers, 2 and 3, are left for which grouping is not possible. Hence, to get a perfect square, 2 into 3 must be eliminated. So we should divide 4056 by 2 into 3, which is equal to 6, to get a number which is a perfect square. Properties of square numbers. Consider the table below, which shows squares of all natural numbers from 1 to 10. Number x: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Square of a number x squared: 1. Perfect square: 1. 4 is equal to 3 into 1 plus 1, which is equal to 4 into 1. 4. 9 is equal to 3 into 3, which is equal to 4 into 2 plus 1, 9. 16 is equal to 3 into 5 plus 1, which is equal to 4 into 4, 16. 25 is equal to 3 into 8 plus 1, which is equal to 4 into 6 plus 1, 25. 36 is equal to 3 into 12, which is equal to 4 into 9, 36. 49 is equal to 3 into 16 plus 1, which is equal to 4 into 12 plus 1, 49. 64 is equal to 3 into 21 plus 1, which is equal to 4 into 16, 64. 81 is equal to 3 into 27, which is equal to 4 into 20 plus 1, 81. 100 is equal to 3 into 33 plus 1, which is equal to 4 into 25, 100. By observing the above table closely, we conclude the following properties. Property 1. No perfect square will end with 2, 3, 7 or 8 at the units place. For example, 33, 217, 538, 16, 357, etc. are not perfect squares. A number having 0, 1, 4, 5, 6, 9 in the units place may or may not be a perfect square. For example, 81, 484, 1225, etc. are perfect squares, but 91, 126, 624, 1700, etc. are not perfect squares. Example: show that the following natural numbers are not perfect squares. 1057. Solution: we know that the natural numbers ending with the digits 2, 3, 7 or 8 are not perfect squares. 1057 ends with digit 7. 7928. 7928 ends with digit 8. Therefore, all these numbers are not perfect squares. Property 2. If a number has 1 or 9 in the units place, then its square ends with 1. The square of a number which has 4 or 6 in the units place will end in 6. Example: what will be the units digit in the square of the following numbers? 31, 21976. Solution: units digit of 31 square is 1 square, hence 1 will be the units digit of the square. Units digit of 21976 square is 6 square, hence 6 will be the units digit of the square, since 6 is the units digit of 36. Examples: what is the unit digit of the following numbers? 209 square. Solution: the units digit of the square of a number having digits at units place as 1 or 9 is 1. 209 square will have 1 as its units digit, while 32 square will have 4 in the units place. Property 3. A number ending in an odd number of zeros is never a perfect square. Examples: are the following numbers perfect square? 64000. Solution: we know that the number ending with odd number of zeros is not a perfect square. 64000 has 3 odd number zeros at the end. Hence, these are not perfect squares. Property 4. Between the squares of the numbers n and n plus 1, there are 2n non-perfect square numbers. For example, square numbers are 1 square, 2 square, 3 square, 4 square, etc. Between 1 square and 2 square, there are 2 into 1, which is equal to 2 non-perfect square numbers, vis-a-vis 2, 3. Between 4 square and 5 square, there are 4 into 2, which is equal to 8 non-perfect square numbers, vis-a-vis 17, 18, 19, 20, 21, 22, 23, 24. Between 6 square and 7 square, there are 2 into 6, which is equal to 12 non-perfect numbers, vis-a-vis 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48. Property 5. The square of an even number is always an even number, and the square of an odd number is always an odd number. Example: determine whether the square of the following numbers is even or odd? 2826, 79. Solution: 2826 being an even number, 2826 square will also be an even number. 79 being an odd number, 79 square will also be an odd number. Property 6. The square of a natural number except 1 is either a multiple of 3 or exceeds a multiple of 3 by 1. The square of a natural number except 1 is either a multiple of 4 or exceeds a multiple of 4 by 1. Property 7. The square of a natural number ending with 5 follows a definite pattern. 25 square is equal to 2 into 3, 100 plus 25, which is equal to 625. 35 square is equal to 3 into 4, 100 plus 25, which is equal to 1225. 45 square is equal to 4 into 5, 100 plus 25, which is equal to 2025. Example: without actual multiplication, find the square of 75, 105. Solution: 75 square is equal to 7 into 8, 100 plus 25, which is equal to 5625. 105 raised to the power 2 or 105 square is equal to 10 into 1100 plus 25, which is equal to 11025. Property 8. The sum of first n odd natural numbers is n square. For example, first odd number is equal to 1, which is equal to 1 square. Sum of first two odd numbers is equal to 1 plus 3, which is equal to 4, which is equal to 2 square. Sum of first three odd numbers is equal to 1 plus 3 plus 5, which is equal to 9, which is equal to 3 square. Sum of first four odd numbers is equal to 1 plus 3 plus 5 plus 7, which is equal to 16, which is equal to 4 square, and so on. In other words, if a number is a perfect square, then it is always equal to the sum of consecutive odd numbers, starting from 1. Property 9. Some square numbers following interesting patterns. Observe the following squares. 1 square is equal to 1. 111, 11 square is equal to 1, 2, 3, 4, 5, 4, 3, 2, 1. If we look at the results of these squares, we find that they have a special property. That is, the sum of the digits of such numbers is a perfect square. 1, 2, 1 is equal to 1 plus 2 plus 1 is equal to 4, which is equal to 2 squared. 1, 2, 3, 4, 5, 4, 3, 2, 1 is equal to 1 plus 2 plus 3 plus 4 plus 5 plus 4 plus 3 plus 2 plus 1 is equal to 25, which is equal to 5 squared. 7 squared is equal to 49. 67 squared is equal to 4489. 666, squared is equal to 44448889. If we look at the results of these squares, we find that they follow another interesting property. Using this pattern, we can find the square of the number 66667 square, etc. Pythagorean triplet. If AB